Hello, everyone. Good afternoon, respected authors and invited guests. Welcome to the technical session 9D. Myself, Gayatri Burguda, and the session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Bangkok, Thailand, and the virtual event is being held through Zoom from 19th to 11th of April 2026. I hope you all will enjoy the knowledgeable sessions throughout the day. In this session, we'll have 10 presentations, and each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any kind of queries or doubts, you can text me in the chat box. And just before we start the session, I would like to introduce you all to the guest for this session, Dr. Seamus Lyons. He is an assistant professor at the International College of Digital Innovation, Chiang Mai University, Thailand, with over 12 years of experience in academia and international education. He focuses on digital transformation and economics. His research interests include financial technology, sustainable digital innovation, and tourism and digital markets, advancing data-driven and innovative solutions. Sir, would you like to address the participants?
Good afternoon. Yes, my name is Dr. Seamus Lyons. I am a Dean at the ICTI College at Chiang Mai University. My area of expertise, if you like, is machine translation, Thai English machine translation, although over my 25, 30-year academic career, I've covered a few natural language processing areas, which obviously includes language models and artificial intelligence. Congratulations on being here today, having your papers accepted, and please enjoy the experience of sharing your research. So I welcome you again, and good luck for your presentation, and enjoy the session. Thank you.
Thank you so much, sir, for your motivational words. Now, I'd like to introduce you all to the second chair for this session, Dr. Archana S. Banet. She is an assistant professor in the Department of Computer Engineering at MIT's Institute of Engineering, Nashik. She has over 19 years of teaching experience and have organized numerous workshops and seminars and published 8 research papers of international reputation. Her areas of expertise include data science, machine learning, DBMS, data mining, and anomaly detection. So, with the introduction of our guests, I would like to move on to our presenters. I would like to call upon the first presenter, Madhusmita Chakraborty ma'am, to present her paper titled A Hybrid RegNet-X Hierarchical Bidirectional Linear Cross Attention Framework for Medicinal Plant Leaf Identification. Ma'am, can you start presenting?
Hello, I'm going to share my slide.
Yes, ma'am, sure.
My screen visible?
Yes, ma'am, it's visible. You may start.
Okay, thank you. Before starting, I would like to request the organizers that on the flyer, my abstract is wrong. Actually, I have shared a different abstract. So I'm requesting to kindly change the abstract and place the correct abstract.
Okay, sure. That will be done, ma'am. Thank you for letting us know. Yes, ma'am.
Okay, thank you. Thank you so much. Okay, good afternoon, everyone. I'm Madhusmita Chakraborty. I'm from Department of PCE, Tezpur University. So today I'm presenting automatic medicinal plant identification method based on RegNet-X backbone. And we have concatenated and fused the RegNet-X features using a hierarchical bidirectional linear cross attention method. So, so let us first know the significance of medicinal plants We all know that all over the world, a lot of people use medicinal plants for the treatment of various diseases, and it is used for traditional healthcare. And 80% of the global population relies on medicinal plants, and it is used for traditional healthcare, and the use of medicinal plants is very much affordable and have it has fewer side effects, and they're also used for food, beverages, and cosmetics. Also the pharmaceutical companies nowadays are moving towards the medicinal plants as everyone is getting aware of the fact that the allopathic medicines have various side effects and are not are very much costly for the common people. So there are several challenges that the medicinal plants face nowadays, because the actual knowledge of the medicinal plants are constrained to the indigenous tribals or the old people in the rural areas mainly. So the generation to generation knowledge transfer is not happening, and that's why there is a knowledge loss. And also there is a that and that's why there is a high risk of incorrect identification, and because of that there may be some issues like wrong use of the medicinal plants, and that may be harmful for the body or health. So that's why we need automatic identification of medicinal plants. Also, the manual identification process of medicinal plants is very much time consuming, and it is prone to error, and it needs expert intervention. As expert taxonomists are not available in the rural areas, in all the areas of the world. So automatic identification will help in that case. Automatic identification using deep learning or AI-based techniques are fast and accurate, and also we can integrate the model into some scalable device or some software applications for the use of the common people. So, for the safer and smarter medicinal plant identification, it helps in reducing in misidentification and therapeutic risk. It also preserves indigenous knowledge, and also it supports biodiversity and conservation of medicinal plants. The also the model can be deployed into some real-time deployment system. So these are main challenges in accurate medicinal plant identification. So main challenges, there are the morphological similarity. So firstly, we can see that Piper beetle and Ficus religiosa, both of the leaves have same heart shape. So the deep learning models may find it tough to differentiate between these two leaves, because they have some same morphological features. Also, the mint and tulsi and Mexican mint, they also have the same uh, morphological structure. Also have the same morphological structure, and also the guava leaves and the sandal leaves and pomegranate leaves, they also have the elliptic structure. That's why it is very tough to identify which leaf is of which plant. And also within the same species, there is morphological variations, as we can see the first row. The first row shows in the figure 2, first row, we can see that these are the leaves of pomegranate leaves, but we can see that there are variations in the leaves. And in the second row, we can see that these are of Mexican mint leaves, and we can see that there is a morphological feature differences. And for the jasmine leaves also, there is morphological feature differences. So let us talk about leaves, why we have chosen leaves as the diagnostic organ or why we have chosen leaves, because leaves have some rich morphological features. So different leaves have different bases, and it has different. Every leaf has some different venation patterns, have different leaf margins and apex, and based on those characters, those features, we can characterize a leaf, or we can classify a leaf. So again, leaves are the most readily accessible and abundant plant organ. That's why if we analyze these features, these leaf features in a systematic way, we can go to automated and reliable plant identification easily using some deep learning techniques, or some machine learning techniques. So to automate the process of medicinal plant identification, and to evaluate our model, we have used 5 publicly available datasets. So we can see in figure 4, figure 4, which shows the dataset wise distribution of images. So the first data set we have used is collected from China. All of these five data sets are publicly available. So the first data set is collected from China. The second one is collected from USA. The third data set is collected from Malaysia, and the fourth data set is from Karnataka and Kerala, is collected from India, and the fifth data set, it is also collected from India. So we can see that all of these data sets are vary in the number of classes, vary in image conditions, and also vary in the background conditions. Also, the first data set, you can see that there is very much variation in the background conditions and how it is captured. There is variations in lighting. That's why it is very tough for a deep learning model to classify or to recognize which plant leaf is which leaf is of which plant. And the second data set, we can see that though the background is almost uniform, but there are lighting variations in lighting. And the third data set, it is
Excuse me,
very,
ma'am. You have
yeah.
1 more minute to conclude your presentation.
Okay, yeah, sure. So here we can see the methodology where I have used RegNetX backbone to fuse features. First, we have taken the features of the shallow for the deep layers, and then we have fused it using hierarchical feature fusion. And then again, the output is fused through the same module, and then linear cross attention fuses the features of the output of the second module and the C2 block. And then these are the blocks I have used in fusion. So these are the results. We can see from figure 8 that our model, the proposed model, gives the best results for each dataset, which shows the generalizability and robustness of our model. So for table 3, it shows the fusion types and some the ablation analysis. And table 2 shows some comparison with existing methods across all the datasets. And our method outperforms all the methods, all the existing methods. So to conclude, we have proposed a HR-HBCF framework that improves medicinal plant leaf classification, and it combines multi-scale spatial and semantic features, and it uses linear cross attention that reduces the complexity while maintaining accuracy, and also bidirectional attention enhances the context-aware feature fusion, and it demonstrates a robust performance across challenging datasets and conditions. These are my references. Thank you.
Thank you so much, ma'am, for your presentation. Sir, do you have any questions?
Hello.
Good afternoon. Okay,
Good afternoon, sir.
Very interesting research. My first
Thank you,
thought,
sir.
My first thoughts were it's very good to see the data sets because you can see the difficulties.
Yes, sir.
When you want to advance your research, which specific area do you think you need to focus? Do you need more data, more clearer data, or is it really a question of like optimizing your different versions of CNNs?
Sir, I think, sir, as we know that CNNs are very much data hungry. So
Sure.
we actually need larger data sets to train on. Also, we need to work on our models also, because the model, though it is robust, but yet it does not show that much better results in the complex data sets, because on data set 1 it gives 93% accuracy, and if we will deploy it in real time it will give much less accuracy than the experimental ones. That's why, sir, we need to focus more on the model development side.
And just a quick final question.
Yes, sir.
The data sets are from different locations. Is it
Yes, sir.
relatively easy or difficult to create these data sets? Are the plants easy to access? The range, is it quite easy to access and create the data sets? Or is there some that are quite rare and difficult?
Sir, because I'm from Northeast India, so we have a very large diversity, biodiversity here. So,
Yeah.
so many plants in Northeast India are yet to be discovered actually. So there are so many rare and endangered plants also, which we can collect. And that is actually, sir, I'm also working on building our own data set from Northeast India. And that is
Yeah.
actually very much difficult, sir, to collect all the data.
Well, good luck with that work. Well done.
Okay, sir. Thank you, sir. Thank you so much.
Archana ma'am, do you have any questions?
Yes, which methods you are going to use for intraspecies identification?
Ma'am?
Hello.
Hello, ma'am.
Which methods you are using for intraspecies identification? Can
Oh,
you
ma'am.
explain?
Yeah, ma'am. This method, we can see the in figure 6, the visual representation of the proposed method. So I have actually used the RegNetX backbone here. First, we have taken the deep features, and we have fused those features using hierarchical feature fusion. And the output of the hierarchical feature fusion block is passed to another hierarchical fusion block, where we have taken a shallow feature of RegNetX, and ultimately the output of the feature is fused using a linear cross attention block. So this is the method we have used for intraspecies variation.
Okay, fine, good.
Yeah.
Thank you so much, ma'am, for your presentation. I would now like to
Thank you.
call upon our next presenter, Intima Mabanza Sir, to present his paper titled Adult Learners' Preferences for Pedagogical Interface Agents, an analysis based on noticeable features. So you may start presenting now.
Okay, thank you. Can I share my screen, please?
Yes, sir, you can share your screen.
Can you please confirm if you can see my presentation?
Yes, it is visible.
It is visible. Okay, thank you very much. Yeah, I'm Tima Wabanza. So I'm going to present my paper. The title is Adult Learners' Preference for Pedagogical Interface Agent, a analysis based on the noticeable features. I'm from Central University of Technology, Department of Information Technology in Bloemfontein, South Africa. This is basically the layout of my presentation. So I'll start with the introduction and then research question methodology, data analysis, findings, and conclusions. So over the years in this digital area, so there have been several pedagogical interface agents which have been developed and also used in various fields. The example of that is e-commerce, entertainment, health, education, tourism, and customer services. So basically, what is the pedagogical interface agent is a piece of educational software which exhibits human-like behavior that communicates with learner in a social, engaging way while guiding them through a multimedia learning environment. Uh, the as the title indicates, so the focus here is on the noticeable features of the pedagogical interface agent. So the noticeable feature, example of that can be the expression, gesture, voice, movement, adaptive feedback, or visual expression. So which basically the interface or what the pedagogical interface agent does. So those noticeable features may affect the user's preference, satisfaction, engagement, and trust of a pedagogical interface agent. So basically, the focus in this study, as I say earlier on, there are different types of noticeable features, but the focus here is basically on 3 noticeable features, which is the appearance of a pedagogical interface agent. So the appearance, basically, I'm referring to the look of the pedagogical interface agent. And then the voice is basically the sound produced by the pedagogical interface agent. The movement is basically the different, the movable actions which are done by the pedagogical interface agent. So adults, the definition of an adult is a person who has attained the age of maturity. In South Africa, if we are talking about maturity, so basically we talk about 18 years and above. So when talking about the studies on pedagogical interface agents, the existing studies, they've focused more on the existing study on the field of pedagogical interface agent. They've concentrated more on younger individual and in educational, whether in educational settings and also broader demographic, but mainly, you know, there's not much have been done in terms of population when we're talking about adults, specifically those who have limited exposure to technology or which have limited exposure to pedagogical interface agent. So the main research question was which features of which pedagogical interface agent features are most noticeable to learners. So by answering this question, basically, we wanted to make two main contributions. The first one was to identify the pedagogical interface agent noticeable feature that can greatly influence learner preference. And then the second one was basically to suggest the design guideline that can assist guiding in developing of a learner-centered pedagogical interface agent. So in terms of methodology, so we had 62 adult learners which had different age. It was also made up of both genders, men and women. So in terms of data collection, so a system was developed which incorporate 10 pedagogical interface agents. Those pedagogical interface agents, they differ in terms of their appearance, movement, and voice. So as you can see there, so those are basically the 10. The first, it was a female text, a male text, a female text and audio, a male text and audio, a female cartoon human, a man human cartoon human. It was a dog, a realistic dog, female, and then male also, the female realistic dog, and then the male realistic dogs. So still in terms of, as I say, the system was developed. So first we start giving those participants initial training. So basically the aim of the initial training was to introduce them on how to use those 10 different pedagogical interface agents, which was incorporated in the system which was developed. And then after that, basically, we gave them some tasks to complete. So in task completion, participant completed word processing tasks using each of those 10 pedagogical interface agents, which I showed you earlier on. And then after that, basically, we gave them the future rating questionnaires. So the future rating questionnaire, its aim was basically to allow participants to rate their preference for each of those 10 pedagogical interface agents, which was incorporated into the system based on 3 noticeable features. As I say earlier on, the focus was on appearance, voice, and movement. So in terms of data analysis, so we did some descriptive statistics. So this is basically the result which we got in terms of those attributes, appearance, voice, and movement. So in terms of appearance, so the first one was the female text, which received more votes. The second one was the male cartoon dog, which received more votes. So the list there, it was the realistic male dogs. So in terms of voice, it was basically the female text and audio, which received more votes, and then it was followed by the male cartoon dogs. So in terms of movement, so the first one was the female cartoon human, so which got 23%, and then followed by the male cartoon dogs. So the least one was basically the female realistic dogs. So in terms of, based on the table which I showed you earlier on, so the general findings of the 3 noticeable features, which as rating of the pedagogical agent as selected by the participants, suggest the following. In terms of appearance, the female text and the male cartoon dog were the highest 2 rates pedagogical interface agent. In terms of voice, it was basically the female text and audio along with the male dog were the most preferred. So in terms of movement, it was the female cartoon human and also the male cartoon dogs were the 2 most liked. So in conclusion, so the results from the study, basically, based on the result for the study, we concluded that the adult learner prioritize the pedagogical interface agent movement, followed by their appearance, and then lastly, their voice. So the findings also reveal that the findings of this study, of this study, basically is going to provide very useful design guideline for developing effective learner-centered pedagogical interface agent system that maximize engagement and satisfaction. So that was basically the end of my presentation. Thank you very much for the opportunity. I'm done
Thank
with
you,
the
sir, for your
presentation.
presentation.
Can I stop sharing?
So, ma'am, do you have any questions?
No questions from my side.
Okay, ma'am. Then I would like to move on to our next presenter. I mean Kicha, ma'am, to present her paper titled Convolutional Neural Network Model Ablation for Accurate Single MRI Super Resolution. You may start presenting.
Hello, can you hear me?
Yes, sir, you're audible. You can start presenting.
Okay, thank you. Okay, just Can you see my screen now?
Yes, sir, it's visible. You may start.
Can you see the slides? Because I can't see.
No, sir, the slides are not visible.
Okay, just on your screen. And now, can you see the slide now?
Yes, it's visible now.
Perfect. Okay. Good morning, good afternoon, everyone, wherever you are. So first of all, thank you for accepting our work to be a part of the conference presentation. My name is Amir Ayab, and I am a senior researcher from the Free University of Bolzano and FBK Research Institute of Trento from Italy. So today I want to have a talk about SRCNN model ablation for accurate single MRI super resolution. So the study explored how different CNN layers and activation function affects the quality of reconstruction medical images. So in the second slide, we have the outline of my presentation. So first, I will start introducing the motivation and the challenge behind the increase in the resolution of MRI using data-driven model. So then I will move to the related work in which I will discuss the advantage and the gaps across different model architecture based on the state of the art. So after that, I will explain in more details the proposed methodology, and in the end, I will discuss the most relevant results and finalize the presentation with the conclusion. So MRI is important in medicine because it provides detailed anatomical information without radiation. However, obtaining high-resolution scan is difficult due to long acquisition time, high scanner costs, and workflow constraints. So limiting the availability of the frequent high-quality images, and this limitation can reduce the effectiveness of advanced device recognition tools. So based on the state of the art, several models have been proposed to address problem of image resolution. It is mainly grouped into CNN-based model, and we have also generative AI like GANs and diffusion model. So actually CNN are simple, efficient, and can work well even with small data sets, making them suitable for defining reliable inference strategies to be used later for the same image modality. For GANs models, it can generate sharper details, but these models have a problem about introduce so in realistic texture. For diffusion models, this kind of model achieve high quality results, but more complex and need more data for training. So the proposed methodology shown in this slide use it to analyze and evaluate different SRCNN architecture incorporates different layers and the activation function. So the pipeline starts first by data augmentation applied to high resolution data using flipping and rotation approach to increase variability and of the data density. Then we generate low resolution data using two approach which reflects a real scenario of a fast scanning and artifact caused by spot amplification during acquisition. And this approach actually, we have mean polling and max polling. Then we generate high resolution images first by applying a bicubic interpolation to make the shape of the data consistent with high resolution. And then we apply CNN layers for to provide a fine anatomical details. Then after that, we analyze a loss. We apply some ablation. Then the best model configuration will be used later for all the data sets. So in this slide, we compare the statistical distribution of low resolution and a high resolution images generated by average polling and max polling. So the results show that average polling reduce resolution while largely preserving the original intensity distribution. And we can see that from the histogram of data distribution. For max polling amplify intensity and produce a much harsher contrast profiling. And we can see from the layouts of the figure and also from the histogram of the density. So this slide show the SRCNN ablation results using the average polling low resolution data set as inputs. So from results, we can see that unit layer with the ReLU activation function, so achieve the highest anatomical fidelity, reaching an R-square of 0.92, and all models maintain a high level of consistency with ground truth data, as you can see from the plot of data distribution, so PDF plot. So when we use model ablation using different activation function, so actually we can see that the best results, of course, is by using ReLU, but also we have likely ReLU can increase the accuracy of the SRCNN model with convolution 2D and FCN. So this slide show actually that the units maintain a stable accuracy when we use maximum polling for low resolution input, while the other architecture exhibits increasing biases under the same condition. And the table summarize the activation function comparison further. And we can see for this case that ReLU activation function provide the most reliable performance across all architecture. So as a conclusion, we can conclude that SRCNN-based unit layer achieved the highest construction fidelity and reaching high R-square with both average polling and max polling to generate low resolution data. So for CNN layers, we can find that, for activation function, we can find that ReLU is the most effective activation function with all architecture of SRCNN, while likely ReLU can improve the accuracy of SRCNN when we use FCN and convolution 2D layers. And as limitation, SRCNN struggle with max polling, low resolution, because a strong intensity of and peaks and the loss of local structure make the signal difficult to reconstruct. Thank you for your attention and any question.
Thank you so much for your presentation, sir. Do our session chairs have any questions?
No questions. Thank you.
Okay, thank you so much.
Okay, then thank you, sir, for your presentation. I would like to move on to our next presenter.
Okay, thank you.
Alia Prameswari Kalyana Markadia Purnomo to present her paper titled Drivers of Gen Z Impulsive Buying, Host, Emotion and Quality in TikTok Live. Ma'am, you may start presenting now.
Okay, thank you. Can you see my screen?
Yes, it's visible. You may start.
Okay, hello everyone. My name is Alia Prameswari Kalyana Markadia Purnomo. I am from Bina Nusantara University, majoring in marketing communication. Now I will present my research. The title is Driver of Gen Z Impulsive Buying, Host, Emotion and Quality in TikTok Live. Okay, first for the introduction section, TikTok live shopping has rapidly transformed the way consumers and brands interact through real-time interactive e-commerce. Live shopping integrates entertainment and purchasing shop entertainment, creating a more engaging consumer experience. Host performance plays a key role in delivering persuasive communication, building trust, and enhancing audience engagement. Emotional euphoria emerge from real-time interaction, excitement, and limited time hours, which can override rational decision-making. Quality value reflects consumers' evaluation of product worth like durability, authenticity, and price fairness, especially relevant in pre-love fashion. The pre-love fashion industry emphasizes sustainability, uniqueness, and personal identity, attracting environmentally conscious consumers. Gen Z is highly responsive to interactive, emotional, and entertainment-driven digital experience, making them more prone to impulsive buying. TikTok Live creates urgency and social pressure, increasing the likelihood of spontaneous purchase. Previous studies often examine these factors separately, with limited research combining cost performance, emotional euphoria, and quality value in one model. There is also a research gap in the context of Southeast Asian micro-entrepreneurs and TikTok pre-love sellers. Therefore, this study aims to analyze how these three factors influence impulsive buying behavior among Gen Z in TikTok live shopping. For the section 2 is literature review. First, live stream commerce and IMC. Live stream commerce combines entertainment, real-time interaction, and transaction in one platform. Within the integrated marketing communication framework, it integrates emotional and persuasive communication to influence consumer behavior. 2. Host performance refers to the host's ability to deliver clear, engaging, and persuasive communication. 3. Emotional euphoria, defined as excitement, enjoyment, and emotional arousal during live shopping. Based on SOR theory, stimulus is live interaction, promotion, and entertainment. 2. Organisms is emotional response. Response is impulsive buying. 4. Quality value represent the perceived trade-off between benefits and cost of a product. 5. Impulsive buying, defined as a spontaneous and unplanned purchasing behavior triggered by stimuli. 6. Research gap. Previous studies mostly analyze variables separately, not in an integrated model. Limited research focusing on TikTok live shopping context, pre-love fashion industry, Generation Z in Southeast Asia. This study fills the gap by integrating cost performance, emotional euphoria, and quality value within the IMC framework. This is my research framework. For the section 3, research methods. For the research design, quantitative explanatory study to examine causal relationship between variables. Research approach, cross-sectional survey using structured online questionnaires or Google Form. Population and sample, for the target is Gen Z. For the criteria is individuals who have purchased via TikTok live shopping. For the sample size is 113.6 respondent. For the sampling technique is purposive sampling. For the variable measure, independent variable is host performance, emotional euphoria, and quality value. And for the dependent variable is impulsive buying behavior. For the measurement indicators, host performance is clarity, responsiveness, interactivity, charisma, product knowledge. For the emotional euphoria, excitement, enthusiasm, urgency. For the quality value is durability, brand value, price fairness, and product condition. And the last of impulsive buying is unplanned purchase, emotional triggers, and instant gratification. For the data analysis technique, structural equation modeling using PLSM, and the two-stage analysis is measurement model and structural model. For the validity and reliability, there are Cronspet alpha, composite reliability, and AV. For the section 4 is result, outer model, all indicators meet the criteria of validity and reliability. 2. Discriminant validity, cross-loading values so that each indicator loads higher on its own construct than on others. 3. Inner model, for the emotional euphoria, is significant positive effect on impulsive buying. For the host performance is not significant. For the quality value is not significant. Number 4 is coefficient of determination or R-square. The model explains 57% of the variance in impulsive buying behavior. The remaining 43% may be influenced by other factors such as social influence, fear of missing out or FOMO, perceived scarcity. This indicates that the model is moderately strong but not exhaustive. For the discussion, so dominance of emotional factors, impulsive buying in TikTok Lab is primarily emotion-driven rather than rational. In line with stimulus, organism, and response theory, emotional stimuli like excitement and urgency directly trigger impulsive behavior. Gen Z is highly responsive to emotional and experiential engagement. For role of host performance does not significantly influence impulsive buying. 3. Role of quality value. Quality value is not significant predictor of impulsive buying. 4. IMC perspective. Emotional engagement is more influential than rational communication. 5. Managerial implication. Emotional strategies are more effective than informational strategies. To increase impulsive buying, sellers should focus on storytelling and entertaining content, urgency, real-time interaction, creating excitement and engagement. Next session is future research. Future research is encouraged to explore additional variables that may better explain impulsive buying behavior in live commerce, such as FOMO, hedonic motivation, social influence, and perceived scarcity. Given that host performance and quality value were not significant in this study, further investigation using mediation or moderation model is recommended to examine their indirect effects through variables such as trust, emotional attachment, or customer engagement. Additionally, future studies should consider applying alternative theoretical frameworks such as hedonic motivation theory or self-regulation theory to enrich the understanding of emotional-driven consumption, expanding the research scope through mixed method approach and cross-cultural or cross-generational samples would also improve the generalizability and depth of insight in the evolving landscape of live stream commerce. For the conclusion, this study concludes that impulsive buying behavior among Gen Z in TikTok live shopping is primarily driven by emotional factors rather than rational or communicative elements. Emotional euphoria was found to have a strong and significant positive effect on impulsive buying, confirming the relevance of the SOR theory in live commerce context. In contrast, host performance and quality value did not show significant direct effects, indicating that persuasive communication and product evaluation alone are insufficient to trigger spontaneous purchase. Instead, these factors function as supporting elements that enhance engagement and provide post-purchase justification. Overall, the findings highlight that emotional engagement plays a central role in shaping consumer behavior in real-time digital shopping environments. So, thank you. That's all my presentation.
Thank you, ma'am, for your presentation. Do we have any questions?
Yes. The findings suggest that the influence is strongly geared towards emotion. And in your future research, you talked about one area was trust. Do you have any interest in looking at the difference between real emotion and fake emotion, as in that the viewer has more trust in that emotion being real rather than not real?
Okay.
Is that of interest of your research?
Sorry, maybe I need to. Can you repeat your question? Sorry, sir.
Your results suggest that emotion is the primary influence. In your future research, you include trust. Are you interested in finding out if the emotion is real or fake is a factor in the influence?
I don't have real emotion.
So your results say emotion is the strong influence. I'm asking, in your research or future research, do you think you'll look at real emotion against fake emotion?
Okay, now I will answer your question. The fake emotion is not in live shopping because impulsive buying, it's meaning real emotion.
I mean the emotion from the presenter.
First, the host truly feel excitement or enjoyment. That happens when they like the product, they are naturally expressive, and viewers may perceive them as more trustworthy. And for the emotion, maybe from the war in TikTok live shopping, so it's real because the audience can engage each other, interact with the host and the other audience. So this means real emotion. It's closer to emotional performance or emotional euphoria. This is not exactly fake.
Okay, thank you.
Okay, thank you, sir.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon our next presenter, Matthew Abraham Cristanto, sir, to present his paper titled How Word of Mouth, Branding, and Exclusivity Shape Customer Visit Intention. Sir, you may start presenting now.
Hello,
Yes, sir, you're audible. You can share your screen. It's visible. You can start.
can you see the screen?
Yes, it's visible.
Okay. Hello everyone, good afternoon. My name is Matthew Abram Kristanto. I'm from Bina Nusantara University in Indonesia. Today, my study title is How Word of Mouth, Branding, and Exclusivity Shape Consumer Visit Intention. Introduction. The food and beverage industry in Indonesia is experiencing rapid growth, driven by urbanization and evolving consumer lifestyles. Modern consumers are shifting from functional consumption towards seeking experiential value, including exclusivity, personalization, and emotional engagement. Experiential venues such as listening bars combine food, music, and social interaction, transforming F&B spaces into cultural and lifestyle destinations. In the case of XYZ Listening Bar in South Jakarta, represents an exclusive concept. Hidden location informed only after booking, reservation only access, limited visiting time, dynamic non-fixed menu, curated vinyl music experience. In this context, intangible factors such as atmosphere, identity, and experience become more important than physical products. Three key marketing variables are identified as potential drivers of visit intention. The first is word of mouth, which builds trust and credibility, branding, which shapes perception and identity, exclusivity, which creates differentiation and perceived value. The rise of digital platforms has strengthened EWAM, making peer communication more influential than traditional marketing. However, there is still limitation research examining how these variables influence visit intention in exclusive reservation-based experiential F&B contexts. Therefore, this study aims to analyze the impact of word-of-mouth branding and exclusivity on visit intention in an experiential F&B setting. Literature review. Word of mouth and IWAM are considered highly credible and persuasive compared to traditional advertising. IWAM accelerates information diffusion through reviews, social media, and shared experiences. Functions as social proof, reducing perceived risk and increasing willingness to try new experiences, particularly important in exclusive and reservation-based venues, where word of mouth acts as an informal access channel. Prior studies shows word of mouth has a positive impact on consumer behavioral intention. Branding in experiential context goes beyond logos, encompassing sensory experience, storytelling, service rituals. Branding also shape how consumers feel, think, and behave toward a place. And this include key dimensions of brand identity, brand image, trust, loyalty, consistency. Place branding is crucial in creating a strong experiential identity. Previous research links branding with behavioral intention, though results may vary by context. Exclusivity is created through limited access, reservation-only system, hidden locations, capacity restrictions. Acts as a scarcity strategy, increasing perceived value and desirability. Attracts consumers seeking uniqueness, status, and novel experiences. And hence, word of mouth as unique experiences are more likely to be shared. Plays a key role in positioning venues as cultural and premium destination. Visit intention is influenced by cognitive factors such as perceived value and brand image, affective factors such as emotion and experiences, social factors such as word of mouth and social validation. Stronger perceptions and social validation increase the likelihood of an actual visits. In exclusive contexts, access barriers influence intention formation, which requires both strong stimulus and convenient access to information and booking. This is the research framework of this study. Research model. The study adapt a qualitative approach within a positive paradigm. Type of research is explanatory research aiming to test causal relationships between variables. The independent variables is word of mouth, branding, and exclusivity, and the dependent variable is visit intention. Primary data are collected using a structured online questionnaire. The target respondents are individuals living in Jakarta and surrounding areas, interested in music or cafe cultures, familiar with exclusive F&B concepts. Sampling method is proposing sampling with a sample size of 384 respondents, which is determined by using the Lamichaux formula with a 5% margin of error. Analysis tool with PLSM using Smart PLS, and the measure model evaluation is convergent validity with outer loading and AVE, and reliability with Cronbach alpha and composite reliability. Discriminant validity assessed using formal Lakers criterion, cross-loadings, and HTMT. Structural model evaluation, hypothesis criteria testing using t-statistics and p-value. Result. All indicators are valid. All constructs are reliable, and convergent validity achieved. Discriminant validity established using Vonnellacker criterion, cross-loading, and HTMT. All variables are distinct and valid constructs. Structural model hypothesis testing. First hypothesis, word of mouth towards visit intention is significant. Second hypothesis, branding toward visit intention, not significant. And third and last, exclusivity toward visit intention is significant. Discussion. Word of mouth significantly influences visit intention by building trust and credibility and providing social validation. Peer recommendations are more persuasive in experiential contexts. Exclusivity shows the strongest impact on visit intention, which acts as a scarcity signal, increasing perceived value, prestige, and curiosity, which aligns with consumers seeking unique and status-driven experiences. Branding has no significant direct effect. Possible explanation is are consumers rely more on peer validation, word of mouth, than brand communication. Brand may work indirectly through emotional connection, perceived authenticity, which suggests branding acts as a supporting factor. Key insight: visit intention is shaped by the interaction of factors, not individual variables. In exclusive F&B setting, word of mouth and exclusivity is more powerful than the branding itself. Consumers prioritize social proof, access limitation, and unique experience. Future research is encouraged to extend the study by incorporating additional variables such as perceived value, customer experience, trust, or consumer motivation, which may act as a mediating or moderating factors in shaping visit intention. Given the insignificant direct effect of branding, further studies should explore this potential indirect role through constructs such as emotional attachment or perceived authenticity. Employing a mixed method approach could also provide deeper insight by combining quantitative findings with qualitative exploration of consumer experiences. Additionally, future research may compare exclusive reservation-based F&B venues with more conventional establishments across different geographic and demographic contexts to enhance generalizability. From a practical standpoint, it is also important to examine the balance between exclusivity and accessibility, as overly complex reservation systems may discourage potential visitors. Conclusion: the study examines the influence of word-of-mouth branding and exclusivity on consumers' visit intention within the context of an exclusive experiential F&B venue. The findings reveal that word-of-mouth and exclusivity has a positive and significant impact on visit intention, while branding shows a positive but insignificant effect. These results highlight that in experiential and scarcity-driven environments, consumers are more influenced by social validation and perceived exclusivity than by traditional brand communication. Exclusivity emerges as the strongest driver, reinforcing the importance of scarcity and uniqueness in enhancing perceived value and attracting consumers. Meanwhile, word of mouth plays a critical role in building trust and reducing uncertainty, especially in reservation-based concepts. Overall, this study contributes to the understanding of consumers' behavior in experiential marketing by emphasizing the dominance of intangible factors and suggesting that branding functions more as a supporting element rather than a primary driver of visit intention. Thank you.
Thank you for your presentation, sir. Any questions?
Hello. Can you explain which of these three factors do you think has the strongest long-term impact on visit intention?
Okay, so from this study, I think that the exclusivity has the best long-term sustainable which shapes the consumer visit intention, because it is the because exclusivity is not only a short-term attraction, but it creates a sustained perception of value and uniqueness over time.
Okay, is this your research topic?
Sorry?
Is this your research topic?
Yes.
Okay, fine. All the best for your future endeavors. Good.
Thank you.
Thank you, sir, for your presentation. Now I'd like to call upon our next presenter, Mohammad Abdul Malik Sowaj, to present his research paper titled Hybrid AI-Enabled IoT Imaging Framework for Early Stage Multilabel Tomato Leaf Disease Detection. So you may start your presentation.
Thank you. Can you hear me?
Yes, sir, you're audible. You may start.
Have a good day, everyone. My name is M. Abdul Malik Shobuj. I am an undergraduate student from American International University, Bangladesh. And today I will present our research title, Hybrid AI-enabled IoT imaging framework for early-stage multi-level tomato leaf disease detection. This presentation is organized into several parts. First, the introduction, why the problem will be discussed. Then the research gap and objectives will be explained. After that, the methodology and the system architecture will be presented. Next, performance comparison and a case study will be discussed. Finally, the advantages, challenges, conclusion, and future work will be presented. Agriculture plays a vital role in ensuring global food security and economic stability. Among many crops, tomatoes are one of the most widely cultivated and consumed worldwide. However, tomato plants are highly vulnerable to various leaf diseases. These diseases significantly reduce crop yield and quality, leading to financial loss for farmers. One of the biggest challenges is that many diseases are detected too late. When the damage is already served, traditional detection methods rely heavily on human experts. These methods are time-consuming, labor-intensive, and not always accessible, especially in rural areas. To address these issues, we propose a hybrid AI and IoT-based framework that enables early-stage and accurate disease detection. There are several limitations in existing systems. First, most systems detect diseases at a late stage, when damage is already done. Second, many models use single-base classification, meaning they can detect only one disease at a time. But in real time, our leaf can be multiple diseases together. Also, real agricultural environments are complex and variable, which affects model performance. Another issue is high computational cost, which makes deployment difficult in rural areas. So there is a need for a lighter real-time multi-level system. The main goal of this work is to develop a hybrid AI IoT framework. Especially the objectives are to support multi-level classification, to enable early-stage detection, to provide real-time monitoring, to ensure a low computational cost, to support edge device deployment, to make the system suitable for real field environments. Our proposed system integrates three key technologies: IoT sensing, edge, and cloud computing, hybrid AI models. At the core of our AI models, we combine CNNs and transformer architectures. CNNs are highly active for extracting local features, such as textures and patterns in leaf images. On the other hand, transformers help capture global dependencies and complex relationship with the image. By combining these two, we achieve both accuracy and robustness. Now, let me explain the system architecture. The system consists of four main layers: IoT imaging layer, communication layer, edge and cloud layer, hybrid AI, and application layer. In IoT imaging layer, camera-based IoT devices capture images of tomato leaves continuously. The devices use RGB sensors and perform basic processing. In communication layer, the captured data is transmitted using technologies like Wi-Fi or LPWAN, ensuring low latency and energy efficiency. At the edge level, initial processing is done to reduce latency. More complex computational are handling in the cloud. Hybrid AI and activation layer. This layer performs disease classification using our CNN transformer model. It also provides features such as visualization, confidence score, alert, and historical analysis. This slide shows the overall architecture of our proposed system. First, IoT cameras captures live images continuously. Then the data is transmitted through the communication layer. After that, initial processing is done at the edge, while more complex tasks are handled in the cloud. After that, initial process, sorry. Finally, our hybrid AI model combining CNN and transformer analyzes the images and provides disease detection results, alerts, and insights to the user. We compared our proposed model with several existing approaches, including CNN-based models, EOL-based systems, and transformer-based methods. Most traditional models support only single-level classification and have limited early detection capabilities. In contrast, our proposed hybrid model achieves high accuracy, high precision and recall, multi-level classification capability, a strong early stage detection performance. This makes it more suitable for real-world agriculture applications. To evaluate our system, we conducted a case study in a peri-urban urban farm environment. We deployed IoT cameras integrated with edge AI processing. The system was able to detect results in real time. The results showed reduced manual effort, faster detection, improved crop management. This demonstrates the practical feasibility of our approach. Our system offers several advantages. It is cost-effective and energy efficient, making it suitable for farmers. It supports precision agriculture
Excuse
by
me, sir. You have 1 more minute to conclude your presentation.
Okay, thank you. There are many advantages in our system. So, however, there are still some challenges. System integration can be complex, especially when combining IoT, AI, and cloud components. The initial deployment cost may be high for some farmers. Connectivity issues in rural areas are also a challenge. In conclusion, we proposed a hybrid AI IoT framework for commercial disease detection. Our system successfully achieves early stage detection, multi-level classification, and real-time monitoring. For future work, we plan to conduct large-scale real field deployment across different regions. Extension to other crops also. Thank you, everyone. Thank you for your attention.
Thank you so much, sir, for your presentation. Do we have any questions?
How your system will handle the overlapping or reoccurrence of disease on the same leaf?
Yes, it can.
Any method you implemented for that?
Yes, we use AI to enable method.
Okay.
Thank you. Thank you so much.
Uh, Okay, thank you so much, sir, for your presentation. Now I'd like to call upon our next presenter, Fahima Sultana Smriti ma'am, to present her paper titled IoT-based smart railway crossing system using sensors for real-time train detection and safety enhancement. Ma'am, you may start presenting now. Can you hear me?
Yes, go ahead.
Okay. Good day, everyone. My name is Smriti, and today I will be presenting our research paper titled IoT-based smart railway crossing system using sensor for real-time train detection and safety enhancement. This study focuses on analyzing and proposing an intelligent railway crossing system using IoT and sensor technologies. The main aim is to address safety challenges in unmanned railway crossings, especially in rural areas. In this presentation, I will explain the problems, background, research gap, proposed model, and the overall significance of the study. Moving to the next slide. This slide presents the outline of my paper. First, I will discuss the introduction to the problem, followed by the research gap identified from existing studies, and then I will explain the research objectives and methodology used in this study. After that, I will describe the proposed model and system architecture in detail. Finally, I will cover the algorithm, power consideration, comparative benefits, and conclude with future research directions. Now, moving to the next slide, it's introduction slide. Railway transportation plays a crucial role in both passenger travel and good transportation. However, railway crossing safety remains a serious issue, particularly in unmanned and rural areas. Many accidents occur due to lack of automation and inefficient monitoring system. Existing infrastructure often relies for outdated or manual system, increasing the risk of human error. Therefore, this study emphasized the need of a smart, automated, and real-time detection system to enhance safety at railway crossing. This study identifies several limitations in existing research and systems. Most current systems are manual and highly dependent on human operators, which reduces reliability. This is also a lack of real-time train detection in many solutions. Power supply issues in remote areas further limit system performance. Additionally, advanced technologies used in some studies are often expensive and complex, making them impractical for developing regions. These gaps highlight the need for developing regions. It's more efficient and cost-effective solution. Now, the main objective of this research is to propose an automated railway crossing system. The study aims to enable real-time train detection using sensor-based technology. Another objective is to minimize human intervention and improve overall system reliability. The research also focuses on developing a cost-effective solution powered by renewable solar energy. Overall, the goal is to enhance the railway safety through an efficient, scalable, and practical approach. Now, moving to the methodology slide. In this study, we analyzed existing approaches such as sensor-based monitoring system and AI-based detection techniques. While AI improves accuracy, it often requires high computational resources. IoT technology enables real-time communication between system components, which is essential for safety application. However, many existing systems face challenges related to cost and complexity. Therefore, our methodology focuses on integrating sensor-based detection with IoT communication while maintaining simplicity, efficiency, and affordability. Now, this is our proposed system. This paper proposes a smart railway crossing protection system. It is an
IoT-based automated model designed to improve railway crossing safety. The system uses a weight sensor to detect approaching train accurately. It is powered by solar energy and includes a battery backup for continuous operation. The proposed design is low cost, energy efficient, and scalable, making it suitable for real world implementation, especially in developing regions. The system architecture consists of several interconnected components. First, a weight sensor detects the presence of a train. The signal is processed by an Arduino Nano. Then a LoRa communication module transmits the data wirelessly to a receiver unit. Based on the receiver signal, warning systems such as LED lights and buzzers are activated. This architecture ensures real-time communication and quick response, which is critical for preventing accident at railway crossing. This proposed system follows a structured algorithm. Initially, the system is powered using solar energy. This weight sensor continuously monitors for train detection. Once a train is detected, the signal is processed and transmitted using the LoRa module. The receiver unit then activates a warning signal for road users. After the train passes, the system automatically resets and resumes monitoring. This cycle ensures continuous and reliable operation. This study also considered power efficiency and practical implementation. The system is fully solar powered and uses a lithium iron phosphate battery for durability and long life. It consumes approximately 6.36 watt hours per day, which makes it highly energy efficient. This design is suitable for rural and remote railway crossings. The system can operate in harsh environmental conditions and provides real-time alert, making it reliable for real-world application. This slide highlights the comparison and benefits of the proposed system. Unlike manual system, the proposed model is fully automated and more reliable. It uses solar energy instead of grid power, reducing dependency on electricity. Real-time alerts improve response time and enhance safety. Additionally, the system is cost-effective, easy to maintain, and suitable for developing regions, making it a practical solution. In conclusion, this study presents an efficient and reliable railway crossing safety solution. The proposed system reduces human dependency and ensures real-time monitoring. It is both cost-effective, energy efficient, making it suitable for large-scale deployment. The research demonstrates how IoT and sensor technologies can significantly improve railway safety. Overall, this study contributes to developing smarter and safer transformation system. For future research, we aim to integrate AI techniques to predict train arrival times more accurately. The system can also be expanded to cover multiple crossings with centralized monitoring. Real-time mobile notification can be added to alert nearby vehicles. Additional sensors such as vibration or infrared can further improve detection accuracy. We also plan to optimize energy management for even better efficiency. Thank you, everyone. Thank you for your attention.
Thank you so much, ma'am, for your presentation. Do we have any questions?
Good afternoon. Your research is very interesting. In your presentation, you said that your system doesn't suffer problems with like failure or severe weather. Did you test that?
No, we didn't actually tested it yet, but we are planning to test it in our future work and for the future development or future research process.
Have you tested it on real crossings?
Yes, we tested it on a rural crossing, but in a very short in a very short environment, like not really in big project or something, in a really short project. So we are planning to doing it in our future works.
Good luck.
Yes, thank you.
Thank you.
Thank you, ma'am, for your presentation. Now I'd like to call upon the next presenter, Subrajyoti Sunani ma'am, to present her paper titled Performance Analysis of UAV Assisted Free Space Optical Communication Link. Ma'am, you may start presenting now.
Hello, am I audible?
Yes,
Hello?
ma'am, you're audible. You can start presenting.
My screen is also visible, right?
Yes, ma'am, it's visible.
Thank you. Hello, everyone. I am Subrajyoti. I'm a research scholar at IIT Bhubaneswar, India, and my topic of presentation is performance analysis of UAV-assisted free space optical communication link. This is the outline of my presentation. I will begin with an introduction, followed by a proposed system and channel model, then discuss the results, and finally conclude with key findings. To start with the introduction, with the rapid growth of data-intensive applications, there is a strong demand for high-capacity systems. However, conventional RF systems may not be able to cater this demand, which suffer from spectrum limitations and lower data rates. Free space optical communication system emerges as a promising solution to this data-hungry demand, offering fiber-like data rate, high security, and license-free operation. Despite the many advantages of free space optical communication system, there are certain limitations in FSO systems, such as atmospheric attenuation, beam divergence and misalignment, turbulence-induced fading. These factors highly affect the performance of FSO communication systems. So what is the role of UAVs in FSO systems? UAVs are used in FSO system as aerial relay nodes. They help maintain connectivity when there is no direct line of sight path between the transmitting station and receiving station. And with the help of UAVs, we can also extend the linkage in these adverse conditions. This is our proposed system model. Here we have a transmitting station, which is at an altitude of 50 meters. We have a receiving station here at the same altitude. There are two UAVs which act as relay nodes, and these UAVs are at 2.5 kilometer distance from this transmitting station and receiving station corresponding. And these two UAVs are at a distance of 5 kilometers. So we have evaluated the performance of this system for different modulation schemes, such as NRZ, RZ, and CSRZ for different weather conditions and turbulence scenarios. The channel is modeled considering these three different factors here. Atmospheric loss and the turbulence is modeled using gamma-gamma turbulence channel model and the pointing error model. So considering these three factors, we have analyzed the performance of our proposed system model for the modulation schemes NRZ, RZ, and CSRZ. This system is simulated using OptiSystem 23. Using this set of simulation parameters, we have taken the bitrate to be 10 Gbps. The turbulence model is taken as gamma-gamma turbulence model. For moderate turbulence, we have taken the refractive index structure parameter as 10 power minus 15, and for strong turbulence case, we've taken it as 10 power minus 12. To analyze the system performance for different weather conditions, the attenuation factor is taken as 0.4 dB per kilometer for clear air. For moderate fog condition, we have taken it to be 9 dB per kilometer, and for dense fog condition, we have taken it to be 25 dB per kilometer. And the transmitter and receiver pointing error angles are taken to be 5 microrads. So let's first see the effect of atmospheric attenuation. Under clear air condition, when the attenuation is 0.4 dB per kilometer, the maximum link range that we have achieved for NRZ scheme is 40 km, for CSRZ it is 39 km, and for RZ it is 38 km. So these values are presented as the link range in between the two delay nodes. And as we increase the attenuation level from 0.4 dB per kilometer to 9 dB per kilometer for moderate fog condition, there is significant power loss, and the reliable range is approximately up to 1.8 km for NRZ scheme. Here, for atmospheric attenuation condition, when we have not taken any turbulence effect, we have observed that the NRZ scheme performs better than CSRZ and RZ. And for dense fog condition, when the attenuation is further increased to 25 dB per kilometer, the signal quality diminishes rapidly, and the effective transmission range is reduced to 1.2 km. These figures shows the eye diagrams for different modulation schemes. Well, the first three figures shows the eye diagrams for 25 km distance for NRZ, RZ, and CSRZ modulation scheme respectively for clear air condition. And the next three figures shows the eye diagrams for 1.8 km distance at an attenuation level of 9 dB per kilometer. The comparison among these three modulation schemes are not clear in this eye diagram. So we have presented a table containing which represents the minimum bit error rate and maximum Q factor associated with these eye diagrams. So from this table, it can be clearly seen that the performance of NRZ being better than RZ and CSRZ. Here you can see that for 25 km distance in clear air at attenuation of 0.4 dB per kilometer, the maximum Q factor is as high as 21, whereas for RZ and CSRZ it is 17 and 19 respectively. Next, we will see the effect of atmospheric turbulence on our system performance. Atmospheric turbulence is the random variation in air refractive index, which significantly impacts the received intensity. Here we have observed that the CSRZ modulation scheme shows better performance compared to NRZ and RZ because of the alternative phase structure in CSRZ modulations. Here, these figures, the first three figures shows the performance of NRZ, RZ, and CSRZ modulation scheme for 1 km distance for moderate turbulence condition, and the next three figures shows for 3 km distance for moderate turbulence. And these three figures shows the performance of NRZ, RZ, and CSRZ modulation scheme for 0.2 km distance under strong turbulence. Here we can see that.
Ma'am, you have 1 more minute to conclude your presentation.
Here we can see that the maximum Q factor for CSRZ modulation scheme for moderate turbulence condition for 1 km distance is 12 for CSRZ and 10 for RZ and 11 for NRZ, from which we can see the better performance of CSRZ compared to RZ and NRZ. So to conclude my presentation, here we presented a multi-hop UAV-assisted FSO system. The use of UAVs effectively extends link range and enables connectivity in non-onerous environment. And we have observed that NRZ is efficient in clear air condition, but CSRZ is the most robust format for turbulence environment. Thank you. Any questions?
No questions from my side.
Okay, thank you, ma'am, for your presentation. Now I'd like to move on to our next presenter, Ethel Jimmy ma'am, to present her paper titled RAD Vision, Topological Data Analysis and Vision Transformers for Automated Radiology Report Generation. Ma'am, you may start presenting now.
Good afternoon. I am Ethel, and today I will be presenting our project, which is RAD Vision, Topological Data Analysis and Vision Transformers for Automated Radiology Report Generation. Am I audible?
Yes, ma'am, you're audible. You may continue.
Thank you. So before I move on to what this paper is about, I'll be giving a brief introduction about why we arrived at this. So basically, medical imaging is essential in diagnosing diseases, as we know, and doctors take about around 20 minutes to generate a radiology report after they have received the scan. So they receive around 80 to 100 or even more than that a number of scans a day. So it's very time consuming for them to prepare a report. So what we do is we aim to give them a first draft report, so it makes their job much more easier. Now there are a lot of systems that are available worldwide, but the problem with most of the systems is the fact that they're black box models. That is, they do not tell you why they arrived at a particular conclusion or a particular inference. So that is very crucial in medical imaging, because like other fields, you cannot simply rely on an inference made by an AI without proper trust. So we plan to bridge the gap between clinical trust and AI by bringing about explainability or proper reasoning as to why it arrived at a particular inference by including TDA, which is topological data analysis. It's a mathematical model that you have used, which provides more understandable or reliable insights from medical images. Also, TDA has been proven in
Okay, no worries. I'd like to call upon our next presenter for the session. I'd like to call upon Aura Mevia Safira Arshia ma'am to present her paper titled When Credibility Goes Viral, Influencer Impact on TikTok Purchase Behavior. Ma'am, you may please start your presentation.
Okay, wait. Okay, can you see my screen?
Yes, it's visible, ma'am. You may start.
Okay. Hello, my name is Aura Mevia Safir Arsya. I'm from Bina Nusantara University, Indonesia. So right now, I would like to present my research entitled When Credibility Goes Viral, Influencer Impact on TikTok Purchase Behavior. Okay, so for the background of this research, social media marketing has become increasingly important for business growth as it helps improve brand visibility, engagement, and customer loyalty. In this context, the harmonization between brands and platform users, especially influencers, plays a critical role in shaping consumer perception. This strategy is widely known as influencer marketing. One of the key factors that determines the effectiveness of this strategy is influencer credibility, which consists of trustworthiness, expertise, and attractiveness. When influencers are perceived as credible, they are more likely to influence consumer attitude and behavior. Moreover, TikTok has emerged as one of the major social commerce platforms, particularly in Indonesia, with more than 108 million active users. This makes TikTok a highly relevant context to examine how influencer credibility affects consumer purchasing behavior. So, there are inconsistencies in understanding how influencer credibility influences consumer behavior. Therefore, further research is needed to examine both direct and indirect effects, particularly in context of TikTok social commerce. Based on previous study, influencer credibility has been found to positively influence purchase intention. And this means that when influencers are perceived as credible, they can increase consumer trust and encourage a stronger intention to purchase the promoted products, as highlighted by CMEC 2021. However, when examined at the dimensional level, the findings become inconsistent. Martiningsih and Setiawan 2022 found that while attractiveness and expertise significantly influence purchase intention, but trustworthiness doesn't show a significant effect. This inconsistency indicates that the role of influencer credibility is not fully understood, particularly in terms of its overall impact on consumer behavior. So here's the framework. Influencer credibility as independent variable, purchase intention as mediating variable, and purchase decision as a dependent variable. A comprehensive examination of existing literature and earlier empirical studies provides support to the following hypothesis. For the hypothesis 1, influencers' credibility has a significant impact on purchase intention. Hypothesis 2, influencers' credibility has a significant impact on purchase decision. And the last hypothesis, influencer credibility has an influence on purchase decision with purchase intention as mediating variable. So here the methodology for research design. This study using positive paradigm with quantitative approach, aiming to examine causal relationship, and this study based on source credibility theory. And for the data collection, primary data collected through online questionnaire with case studies like the TikTok influencer distributed via Google Form. And participation was voluntary with anonymity and confidentiality assured. Measurement using Likert scale. For sampling, the study using purposive sampling technique with the criteria are above 17, residing in Indonesia, have few influencers promotional content. And in this questionnaire, screening question applied, and the sample size is 100 respondent, which meets PLSM minimum sample requirement. For the data analyzing, the study using structural equation modeling partial least square method with using Smart PLS software. For the analysis stage are outer model and inner model. So for the result, for convergent validity, all outer loadings are above 0.7, and for the reliability, all Cronbach alpha values above 0.7, and for all composite reliability values are above 0.7, and all AVE values exceed 0.5. And for discriminant validity, the study using cross-loading and all the highest loading indicators on the construct. So the conclusion, all constructs are valid and reliable. And for the hypothesis testing, hypothesis 1, influencer credibility has a significant impact on purchase intention, are not significant. And for hypothesis 2, influencer credibility has a significant impact on purchase decision, are significant. And the last hypothesis, influencer credibility has an influence on purchase decision with purchase intention as mediating variable are significant. This result show that influencer credibility significantly affect purchase intention and not affect purchase decision. Additionally, purchase intention mediates the relationship, indicating that consumer intention plays a crucial role in converting credibility into actual purchasing behavior. So for the future research, it's recommended to extend this model by incorporating moderating variables such as consumer emotions, product involvement, and social trust to better understand the dynamics of digital consumer decision-making. Additionally, future studies may explore different social commerce contexts beyond TikTok to examine whether the relationship between influencer credibility, purchase intention, and purchase decision remain consistent across platforms. And for the conclusion, this study concludes that influencer credibility has a significant positive effect on purchase intention, indicating that credible influencers can effectively shape consumers' willingness to buy. However, influencer credibility doesn't directly influence purchase decisions. Instead, its effect is fully mediated by purchase intention, meaning that consumer must first develop an intention before making an actual purchase. These findings highlight that credibility function as a psychological driver rather than a direct trigger of behavior. Therefore, in the context of TikTok social commerce, building trust, authenticity, and emotional connection is essential to strengthen purchase intention, which ultimately leads to purchase decision. Thank you.
Thank you so much, ma'am, for your presentation. Do we have any questions?
Yeah, you're saying that the influencer doesn't change behavior but boosts intention, if you like, with their credibility. Did you label parts of their credibility like trustworthiness, expertise, other factors?
Sorry, can you repeat the question?
When you say credibility,
Yeah.
did you cover different types of credibility, like expertise and trustworthiness? You did a survey of the users
Influencer
of
credibility.
yeah,
Credibility.
and in the credibility, did you ask your users what type of credibility, such as trustworthiness, expertise, or other more personal preferences like personality, etc. Did you just use one credibility factor, or did you ask users about what type of credibility?
Okay. Yes. Credibility has different dimension, but I use it as one overall construct, not separated.
Oh,
Yeah.
okay. Thank you.
Okay.
Thank you, ma'am, for your presentation. Now, I'd like to call upon Ekling Kaur ma'am to present her research paper. Ma'am, you may start presenting.
Hey, good morning. One second, let me quickly screen share. Can you confirm you can see my slide? Okay, I'm
Yes,
assuming
ma'am,
that
it's
you
visible.
yeah.
You can start now.
Okay. I think good morning, good afternoon, based on everybody else's time zone. It's 3 a.m. for me right now, and I am on call. I am glad I did not get paged. A perfect day to present my paper. So welcome everyone. My name is Ecleen Kaur. I am a graduate alumni from the University of Florida. I am currently based in California. So today I'm going to be talking about my third installment of our research that is in cryptoeconomic risk. So we are focusing on traditional continuous models fail for high beta altcoins and how we bridge the gap using term diffusion. So this presentation details our third paper. We presented our first paper in December 2025 at RTET, and then the second paper was presented at ICICT London in February. So for this paper, we are focusing on cryptoeconomic risk modeling for cryptocurrency asset class. And we are moving beyond continuity by addressing the structural inability of traditional Gaussian frameworks to model high beta altcoin portfolios. We will present a multivariate Merton jump diffusion model integrated with exponentially weighted moving average governed covariance structure to quantify the specific crash zone characteristics of decentralized assets like Zarpi, Solana, and Cardano that are used for this study. So most literature treats Bitcoin as a proxy for the whole market. We argue that the altcoins have a unique risk architecture. We are filling the gap between univariate Bitcoin studies and the need for multi-asset altcoin portfolio management. So, to highlight some details in the prevailing literature, notably by Professor Crane, that was on his study in 2025, he made strides in modeling rough volatility for Bitcoin. But a significant gap still remains because the assumption that Bitcoin is a representative proxy for the entire asset class is something that I wanted to focus in this work. And personally, as a researcher, I find that there's a huge dearth and shortage of existing literature that are focused on altcoins. So empirically, altcoin microstructures exhibit higher jump intensities and idiosyncratic to code jumping behaviors. So they are independent of Bitcoin's price paths. Standard continuous frameworks like geometric Brownian motion fail to account for these liquidity gaps, and we established this claim in our paper one that led to nearly an 80% underestimation of tail risk using the metrics that we used for estimating the benchmarks. So we have come quite a distance from our paper one. We ground our work in the evolution of portfolio theory, while Markowitz's mean variance framework defined risk through the first two moments. It assumes a continuous diffusion process. In the context of altcoins, we argue that diffusion component it's insufficient. So we must transition from a pure Brownian filtration to the one that includes a jump process and recognize that altcoin returns are fundamentally non-Gaussian and leptokurtic. So in this paper, our previous paper successfully identified the limits of static geometric Brownian motion by introducing conditional volatility, specifically by comparing three models. One was exponentially weighted moving average, second was GARCH, generalized autoregressive conditional heteroskedasticity, and third was iGARCH. So using these models, we proposed the heavy reliance on the assumption of price continuity. So we established the infinite volatility persistence in paper two as a prerequisite for regulatory grade value at risk in altcoins. However, even these GARCH family improvements assume that volatility evolves as a continuous stochastic process. This current study, paper 3, marks a significant evolution by demonstrating the conditional volatility alone cannot capture flash crashes. So by implementing the Merton jump diffusion framework, we improve upon the non-stationary foundations of paper 2 and added a discontinuous Poisson component, effectively bridging the gap between persistence volatility and sudden liquidity shocks. So we're not reinventing the wheel here. We are evolving the Markowitz framework. While traditional models assume prices move smoothly, altcoin jumps. So our study moves from some smooth diffusion to a discontinuous stochastic process. This is the heart of the paper. We add a Poisson component to the standard stochastic differential equation. This means we expect on average 2 major liquidity shocks per year per asset. We also use a compensated jump term to keep our drift estimates unbiased. Here we define a stochastic differential equation. The price of an asset at time t is modeled as a mixture of Wiener process, that's differential of WT, and a compound Poisson process. So referring to the equation that you can see on the slide, the term mu minus lambda zeta represents the compensated drift. So it's there to ensure the process remains a martingale relative to its filtration. Zeta is defined as the expected relative jump size. The term differential of NT is our Poisson operator with intensity chosen as lambda 2.0, governing the arrival of discrete shocks. So we assume the jump magnitude is log normally distributed, introducing the third and fourth moments necessary for accurate VAR estimation. So VAR is our risk metric that we have used for this study, both in paper 1, paper 2, and paper 3. And so for understanding how our models are specifically built, so altcoins don't really crash alone, they crash together. And we use exponentially weighted moving average to stay sensitive to recent market regimes in our model, and Cholesky decomposition to ensure that when one asset jumps, the others in the portfolio reflect that correlated stress. Cholesky decomposition has also been one of our fundamental theories since paper 1. We have used it for modeling our improvements. So to address non-stationarity, we employ exponentially weighted moving average covariance matrix. So unlike sample covariance, EWMA assigns higher weights to recently realized variances, so which is critical for capturing volatility clustering that is seen in altcoins. So we apply the Cholesky factorization, that is sigma and traversal of the matrix that calculates the weights based on their historical values to the diffusion components. This allows us to simulate correlated paths where stochastic shocks are synchronized across the portfolio, effectively modeling the contagion channels that are identified in the high volatility regimes. So we ran the 2 simulation models, and I'm running short on time, so I'm going to take this super fast. Model 1 shows what happens in a pure mathematical vacuum, and Model 2 is a real-world version where we cap the returns at plus minus 10% to prevent the infinite growth errors common in standard jump diffusion simulations. So what this means is that Model 2 introduces a capped return methodology that is very unique to this paper and the existing literature around altcoin portfolio class today. By applying a non-linear mapping to returns, we simulate the circuit breaker, and this effect causes the liquidity depth constraints of actual exchanges to get modeled more closely. We also prevent the pathological exponential growth that this Model 2 is trying to control. And this occurs in long horizon MJD simulations. So yeah, we wanted to leverage this effect by where positive jumps can lead to unrealistic outliers. So here we see the crash zone with high growth and Model 2. These are pretty much the results of our whole research. So Model 2 shows a 4.17% chance of loss by capping the upside. And we actually reveal that how vulnerable the portfolio is to downward jumps when there's no pump to buffer the fall.
Excuse me, ma'am. You have 1 more minute left to conclude your presentation.
Yes. So yeah, these are the highlights of our crash zone, and we have concluded that our model 2 yielded a chance of loss that is 4.17% compared to the baseline. So for testing our model, we did not just believe that this is a theoretical exercise. We backtested the model at QPIC's proportion of failure test, and our results did deem that against 4 years of historical data, we confirmed that MJD framework has statistical stability. The model is not perfect. We acknowledge that the jump intensity might be self-exciting, and there's slippage in altcoin markets that can worsen than simulated. So for the future work, we expand the asset count to improve the weight distribution. We acknowledge 3 primary limitations. First is the jump intensity that is currently static. We intend to move towards self-exciting Hawkey's processes. Second is the subset, so class. We want to extend the subset class. And third is to eventually integrate Kyle's lambda to account for price impact and slippage, which our current simulation treats as exogenous. So in conclusion, this is what we believe, that jump diffusion framework is essential and quite meaningful for altcoins. We have successfully modeled the crash zone, provided a tool for more realistic risk management. And for the MJD and EWMA framework, this provides a much more stable risk management that we established in paper 2 and paper 1. Yeah, and we hope that this can actually fill a lot of literature gap that is non-existent around altcoin portfolio class. Okay, so that's it for my presentation. For only those who were listening to me so far, thank you so much for your time, and thank you so much for patiently listening to me. I'm open to questions.
Thank you so much, ma'am, for your presentation. Do we have any questions?
What did deliver?
No question from my side. Nice presentation, ma'am.
Department department.
Okay, I think we don't have any question from the session chairs. Thank you so much for your presentation, ma'am.
Thank you. Thank you so much for your time.
Now
Hi.
I'd like to call upon
Excuse me.
the
Hello.
last yes.
Hi, I'm really sorry for interrupting. Ethel here. I believe I got disconnected in this presentation. Was I audible properly? Or should I just swiftly continue from where I left off? I'm really sorry for interrupting.
Ma'am, can you please continue after the current slot?
Oh, okay. Thank you. Sure.
Yes, ma'am. Now I'd like to call upon Dr. Ambeka to present her research work. Ma'am, you may start presenting now. Yes, ma'am, you're audible. You may start.
Very good afternoon, everyone, respected session chairs, team and participants, Professor from Engineering College, India. I'm here to present a research paper, implementation of smart system using IoT-based real-time monitoring. So in today's presentation, I'm going to discuss all these points. So the core objective of study is to improve the efficiency and safety of order traffic through integrating sensors, security cameras, and GPS. So in a closed system, it enables continuous monitoring of traffic and environmental conditions. So we specifically target the critical pain points, condition, air pollution, and emergency response delays. So our approach is grounded in real-world success, many case studies from Singapore and Barcelona. So as we all know that because of organization is predicted that nearly 70% of the population will live by 2050. So the time of traditional tracking systems are often static and fluctuations. So to overcome this, we have working to four objectives. So first, aim to transform traditional traffic system into adaptive intelligent model. Flow and safety through real-time monitoring. Second, we leverage our decision-making to significantly reduce pollution. Third, our system extends beyond just vehicles quality and infrastructure, considerable reduction in fuel consumption and carbon emission. Finally, we establish a centralized framework integrating our sensors, GPS, and technology to facilitate seamless data collection informed urbanization. So this is the system. This diagram illustrates how we move from data to intelligent action through functional layers. Layer, this is a sensory system of the city. We use global 5G sensors, means airline sensors, GPS devices, CCTV cameras, sensors continuously gather live information from the streets. This condition is the foundation of the entire system. So in centralized consent infrastructure. So here this location using before 4G or 5G networks. The data is sent to a control center. Here we have servers to perform heavy duty analysis, turning this information into actionable insights. So finally, the application where this is to physical action, the systems and communicate with the vehicles emergency responses to ensure that police and police so as you see in the below the so decision making significantly improves public safety through emergency alerts. So these are the main algorithms what we have used in the system is a traffic action model. So we take historical traffic data and feed it to the STM. STM is what the to predict. So we are using to predict the future condition level. The model is using means by assist to ensure prediction accuracy. The second is detection. So to unexpected disruptions, we implemented using this algorithm. So here we scan clustering. So it's a based spatial clustering application with logs. So here it's already a few data show a speed of 0 kilometer or 100 kilometer per hour speed. But everyone else is kilometer per hour. They don't fit into the crowd. So this is a simulation for research. So here the data we use for simulation. We have used simulation 3 application of simulation for vehicles. We have MQTT, that is a message queuing telemetry transfer. So achieving a latency of less than 20 milliseconds, which is critical simulation. So we trained a STM city bus and UCI accuracy. So here the system type and record throughput. So here some question of data throughput measured data. As you see in this figure, there is a massive performance gap between baseline and smart system. So here, additional baselines struggle significantly barely achieving 80 data in the decimal system scale. Sigma real time. It maintains a steady and efficient successful management of 800 vehicles per hour. So the technical performance comparison as well as table. So here we observe that reduction in rate at the intersection. The baseline rate is of 30 seconds between morning and evening sessions. Our system consistently kept those averages lower into the so here the system actually had an average of 22.5%, total jump from 88.3 baseline accuracy in peak hours reached 20.7%. So from this, the presentation, so in this system has significant improvements for 2.3% of increase in traffic flow and 37% reduction in waiting time and 20% in consumption and 24% emissions. So here, so what I want to conclude here is, so the system, so it enhances the judgment safety and environment and sustainability. So the challenges here is scalability, cybersecurity, and technology integration. So the future advancement, we would like to go with the mobile system. So where it will simultaneously monitor like different systems like buses and trains, public transport like pedestrians and cyclists, emergency services and automobiles, all those things. So with this, I conclude my presentation. Thank you.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon the last slot of today, Ethel Jimmy ma'am, to present her research paper. Ma'am, you may present.
Yes, ma'am. I'm really sorry for interrupting because I got my left off earlier. Could you please tell me where I actually got cut off? Because I kept pressing it, thinking I was still available on the Zoom meeting. So should I continue from there or should I start off from the beginning?
Ma'am, you can continue from where you had left. I think that will be fine.
Can I continue with the problem statement?
Yes, you can.
Ma'am, can you continue from the proposed methodology and then the results? Yes, ma'am.
Sure. So
yeah, please continue.
Okay. Thank you so much. So this is the methodology we have used. The admission workflow consists of the following steps. First is the image upload. So basically it's in a DICOM format image. That's a regular medical image that is being used worldwide. So the image is being uploaded. After that, it is pre-processed. That is, it is normalized and resized. And then it is given to the vision transformers for feature extraction. And then it is combined with the extracted features from topological data analysis, that is the persistent diagram features, and then it is given for classification, that is to the random forest classifier is what we have used to predict the abnormalities, and then it is given to the transformer for the report generation. AI generates a structured radiology report from what it has received from the VIT and TDA features. So the VIT basically divides it into 16 into 16 patches and gives a 728 embedding vector, which is then combined with TDA. That is what we are giving to the transformer to derive the results. So this is a system architecture. It's a radiologist dashboard. The radiologist can store his or her patient scans, and the scans of a particular patient appear in the MongoDB as well. So it's very much integratable with the hospital system. Now, this is the AI modular architecture. We have used Vision Transformers TDA to generate the report. This is just like how I explained earlier. So this is regarding the data set. We have used Stanford's MRNet dataset, which consists of knee scans, which consists 1,370 knee MRI scans, which consists of 130 training and 120 splits of validation tests. The knee scans are basically divided into 3 slices, that is sagittal, coronal, and axial. There is a side view, front view, and the top view, which is normally used for detecting ACL tears or meniscus injuries or other general abnormalities. So this is the data set we have used. And these are the 3 types of scans. Now, talking about topological data analysis, it's a mathematical model, like I told earlier. It is used to identify connected components or loops or voids and understand meaningful patterns and the shape analysis and any subtle abnormalities which cannot be visible to the naked eye. So this is the Persistence diagram, and it consists of a birth and a death chart and a diagonal. As you can see, the orange dots there represent noise, which are not really important in understanding the features or understanding the abnormalities. The ones in the blues are the actual ones that are responsible for a particular injury or like maybe a tumor or something. So this is a reset analysis with the confusion metrics. It shows the recall, precision, accuracy, and the ROC. Yes, ma'am. Hello.
You can continue, ma'am.
Okay. So this is the accuracy. It's between 70 to 80. That is because of the data set we have used. Though it contains a lot of data, it does not have maybe that much amount of ACL tears or abnormal or meniscus injuries. That is why there is a low precision, that is between 70 to 80. That is because of the data set. Now, the limitations are it requires a large data set, and AI prediction, they still need human verification. Though we have GradCam and TDA and explainability, you still require a radiologist because it's related to the medical field. And we have trained it only on the knee MRI scan. The next one is the vision transformer model we have used. Though it's a black box model, we have included TDA as well to bring about explainability. And the system can automatically analyze knee MRI scans. Now I'll just move on to the output, if I may. So this is how the output looks like. You can see the axial, coronal, and sagittal view. And then at the right end, you can see 3 pictures. This is the GradCam. It shows you why the AI arrived or came about a particular inference. So the first image is an EMRI scan. The second image is the GradCam, and the third image is an overlay or a superimposed image of the MRI scan and the GradCam. So it's very easy for doctors to identify why it arrived at a particular conclusion. And it also comes with the persistent diagram and the explanation for it as to why there is an abnormality. And once it's given, you can get a report like this, which is editable by the doctors. And the doctors can edit it, and only after the doctors edit it and sign it with their name can this be downloaded and then integrated to the hospital system. So this is how the output looks like of the project. It has the radiologist notes, the impressions, the findings, and the techniques. So this is the output, and these are the references we used. Thank you for giving me your time, and please do ask any questions.
No question from my side. Nice presentation.
Thank you, ma'am.
Thank you for your presentation, ma'am. And with that, we have completed all our presentations for today. So I would like to move towards the closing remarks for this session. I would like to sincerely thank all the authors for their excellent presentations and contributions in this session. and all our participants for being a part of this international conference. I hope this session was informative enough for all of us. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. And we'll be happy to have you in the 12th version in 2027 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would like to thank our session chairs, Dr. Seamus Lyons and Dr. Archana S. Bennett, for chairing this session. Here is a token of appreciation to the session chairs on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you so much to the respected session chairs for their valuable presence. Before finally ending the session, I kindly request you all to switch on your cameras for a quick snapshot. Can you all please switch on your cameras? Okay, we are now finally done with the session. You all may now leave the session. Thank you so much for joining. Stay safe and take care. Thank you.
Thank you.
Bye-bye.